In the universe, weather is nothing like we know it. On Venus, it rains acid. On Mars, storms can grow so massive they swallow the entire planet. This audiobook is an invitation to close your eyes and travel far beyond Earth, to worlds where the skies behave in ways that are as strange as they are beautiful. Every planet has its own personality, its own secrets, and of course, its own climate. Imagine Venus, a planet so hot it could melt lead. Yet despite its hellish temperatures, the winds in Venus's upper atmosphere blow with such force they could sweep away anything in their path. How can such a hostile world harbor winds like that? That's just one of many questions we'll explore in this journey. Venus is also home to powerful hurricanes. But what triggers them? And could there, against all odds, be life hiding in its thick clouds? Some scientists believe that despite the extreme environment, certain conditions in the upper atmosphere of Venus might allow microscopic life to exist. Imagine that! A planet that seems utterly inhospitable might hold the key to one of humanity's oldest questions. Now, let's drift toward Mars, a planet shrouded in mystery. Mars is not just home to ancient riverbeds and the largest volcano in the solar system. It's also known for its enormous dust storms, capable of covering the entire planet for weeks. Picture a storm so massive it could blot out the sun in a world already veiled in desolation. What causes these storms, and why are they so destructive? To understand Martian weather is to uncover how its climate changes with the seasons and how it compares to our own planet. Sandstorms on Earth are nothing new, but did you know that on Mars they can stretch across the globe and alter the entire atmosphere? Such comparisons open up new questions. What other secrets does the universe hold about the dynamics of alien skies? Our next destination? Jupiter, the giant of our solar system. Here, weather exists on a scale that defies human imagination. Jupiter is home to the Great Red Spot, a colossal hurricane that's been spinning for centuries. What keeps it alive? The planet's intense internal gravity plays a key role, fueling an endless cycle of violent atmospheric activity. And even here, in Jupiter's hostile skies, scientists have speculated about the possibility of life. Could there be life in the clouds of a gas giant? The idea may seem far-fetched, but the search for life pushes us to reconsider what habitable really means. Now let's drift towards Saturn, a planet famous for its stunning rings and equally fascinating for its weather. Massive electrical storms light up its skies. These tempests are not just beautiful, they reveal the complex chemistry of Saturn's atmosphere. And then there's Titan, Saturn's largest moon. Imagine a world where it rains liquid methane instead of water. These alien rains carve rivers and lakes into a frozen landscape, reshaping our ideas of what life could look like in the most unlikely places. What kind of organism could survive such cold, such chemistry? Now we drift even farther, to Neptune, the most distant planet from our sun. Here, frigid winds race at over 1,200 miles per hour. It's a frozen world shaped by forces we still don't fully understand. The planet's violent weather leads us to deeper questions about how it formed and how its climate has evolved over time. As we search beyond our solar system, a new frontier emerges, the hunt for storms on exoplanets. Could there be megastorms swirling across the skies of distant worlds? If so, what could they reveal about the atmospheres of other star systems? The answers may reshape our understanding of how planets and even life itself emerge across the galaxy. Comets also play a part in this cosmic drama. These icy travelers are more than relics of the solar system's birth. Some scientists believe they may have brought the ingredients for life to Earth. But comets also remind us of something, that the universe is not only filled with wonder, but with danger. As we venture deeper into space, telescopes and probes give us a clearer view not just of alien weather, but of ourselves. The search for life, the colonization of new worlds, and the protection of our own planet. These are no longer distant dreams. They are our shared future. This journey through planetary weather is more than a scientific quest. It's an invitation to reflect on our place in the cosmos and the fragile thread that connects us to every world we study. So join me. Let's explore together the strange, beautiful, and sometimes terrifying climates of the universe. Could life ever adapt to an environment where the temperature exceeds 400 degrees Celsius and the atmosphere is as acidic as sulfuric acid? Such questions challenge everything we think we know about the limits of life in the universe. And yet, Venus is just one example of a world with extreme weather. Mars, the fourth planet from the Sun, offers its own set of dramatic climate events. The dust storms on Mars are so massive they can engulf the entire planet for months at a time, creating an apocalyptic haze that turns the Martian sky into a swirling sea of rust-colored clouds. Can you imagine an entire planet cloaked in a dust storm? These storms are triggered by the changing seasons on Mars, seasons not unlike Earth's, though longer and colder. When we compare Martian dust storms to Earth's sandstorms, the differences are striking. Our storms tend to be local, brief, but on Mars, they can stretch across thousands of kilometers and last for weeks, even months. What does this mean for our dreams of exploring the Red Planet? How do such storms affect our rovers, our landers, and the delicate instruments we send there? These are the questions that guide us deeper into the study of alien weather. Next, we return to Jupiter, the king of storms. This gas giant doesn't just have weather, it has megastorms. The Great Red Spot is the most famous of them all, a swirling vortex larger than Earth, spinning for centuries without pause. But it's not alone. Jupiter's fast rotation and turbulent atmosphere give birth to storm systems that evolve and persist in a dance of chaos and order. What powers these eternal tempests? The answer lies deep within Jupiter itself. The planet's internal gravity generates immense heat and pressure, fueling the energy needed for storms to thrive across generations. Even here, amid poisonous gases and crushing winds, scientists have wondered, could there be life? Though it seems unlikely, some researchers speculate that Jupiter's clouds might contain the basic ingredients for life, hidden within this colossal, violent world. Is it possible for life to evolve in such alien conditions? As we continue our journey, Saturn emerges from the dark. With its majestic rings, Saturn is more than beautiful. It's electric, literally. Massive lightning storms rage across its surface, releasing bursts of energy that ripple through its atmosphere. These storms are not only mesmerizing to watch, they may also mimic the chemical reactions that once sparked life on early Earth. Could Saturn's tempests hold clues to our own origins? Then there's Neptune, the most distant and coldest planet in our solar system. Despite its icy environment, Neptune hosts the fastest winds ever recorded, faster even than Jupiter's. Winds that exceed 1,200 miles per hour. How do such forces exist in a place so cold and distant from the sun? These winds raise new questions about how atmospheres form, evolve, and sustain energy in the outer reaches of the solar system. Together, these worlds remind us that weather is more than just a backdrop. It's a story, a record of planetary history, and possibly a window into the potential for life. Which brings us back to Venus. You may wonder, could clouds on a world like Venus, dense, toxic, and unrelenting, harbor signs of life? To many scientists and dreamers, the answer might just be yes. Though the surface of Venus is a scorched wasteland, temperatures higher in the atmosphere, around 60 degrees Celsius, are surprisingly moderate. Here, the thick clouds form a kind of atmospheric blanket, not safe exactly, but different, less deadly. Some scientists have proposed that microbial life could exist in these layers, tiny organisms floating in the upper atmosphere, much like extremophiles do in Earth's harshest environments. On Earth, certain microbes survive in extreme heat, intense acidity, or total darkness. Could similar life forms adapt to the skies of Venus? One key mystery: how would such organisms get energy? Photosynthesis seems unlikely. The clouds of Venus are so dense they block most sunlight. But there's another possibility. Some researchers propose that chemical reactions in the atmosphere itself could provide energy, a form of life that doesn't depend on sunlight, that doesn't live on a surface, that floats in acid and thrives. It's not science fiction. It's science that dares to ask, what if? In 1980, the Soviet Venera probes transmitted data from Venus's atmosphere that hinted at something remarkable: traces of phosphine gas. On Earth, phosphine is produced by microbes and other biological processes. While this finding is far from conclusive, it raises one haunting question. Could something be alive up there? Venus is a brutal place to explore. The pressure near the surface is like being a kilometer beneath the ocean. Yet our curiosity persists. What could we learn if we sent floating probes to drift in those acidic clouds for weeks or even months? What secrets might they uncover? What evidence might they find, not of civilization, but of biology, chemistry, and life that rewrites the rules we thought were unbreakable? The idea of life in the clouds of Venus may sound like a fantasy, but science has always pushed beyond what seems possible. And time again, the impossible becomes real.
Who would have imagined that life could be found in the most extreme places on Earth, like the crushing depths of our oceans? If life can survive there, perhaps it's not so far-fetched to imagine it floating high above Venus in the shelter of its clouds. The search for life in Venus's atmosphere should not be dismissed. Each discovery brings us one step closer to understanding the incredible complexity of life in the universe. Future missions to Venus could reshape our view of this mysterious planet. Proposals are already underway to send high-altitude balloons drifting through the clouds to collect samples and study the atmospheric chemistry. What might we find on such a voyage? The idea of life existing in such an unexpected place challenges us to rethink how and where we search for life elsewhere. Venus, in this sense, becomes a natural laboratory for astrobiology, the science that explores how life might exist beyond Earth. How can life adapt and survive in the most extreme environments? What planetary conditions are truly necessary for living organisms? Venus offers clues to these questions, clues that may help guide future missions to even distant worlds. The possibility of life, even microbial life, in the clouds of Venus reminds us that the universe is full of surprises and still holds secrets waiting to be discovered. The journey continues, and so must our curiosity. What lies ahead in the search for life on Venus? With science advancing rapidly, answers may be closer than we think. Life in Venus's clouds is no longer just a dream, it's a frontier, a call to explore the outer edges of our knowledge. The story of Venus is a reminder that sometimes the answers to our deepest questions are found in the most unexpected places. Meanwhile, across the solar system, Mars tells a story of wind and dust, forces that shape its barren surface in powerful, poetic motion. Did you know that on the red planet, dust storms can grow so massive they envelop the entire world? Martian weather is not just about temperature, it's about movement, a swirling, seasonal dance of fine particles that reshape the land over time. Each year, as Mars reaches its closest point to the Sun, called perihelion, a chain reaction begins. Rising temperatures cause carbon dioxide ice at the poles to sublimate into gas, agitating the atmosphere. This disturbance can trigger the start of massive dust storms. These storms are unlike anything we experience on Earth. They don't just crawl across the ground, they rise. Some reach so high they touch the edge of space itself, climbing into the upper layers of the Martian atmosphere. Can you imagine standing on the Martian surface and watching a tower of dust ascend into the stratosphere? Martian seasons are longer than Earth's, each year lasting nearly twice as long. The changing weather patterns, influenced by the planet's axial tilt and elliptical orbit, play a major role in storm formation. When spring arrives in the southern hemisphere, rising temperatures set the stage for colossal storms that can darken the skies for months. What's truly astonishing is how this planet-wide weather system transforms the very shape of Mars. Winds can reach up to 100 kilometers per hour, not extreme by Earth standards, but on Mars, with its thin atmosphere, it's enough to cause significant erosion. Over time, these winds carve valleys, smooth plains, and build mountains. Every storm is a sculptor, every gust a whisper from the planet's geological past. But not all storms are equal. Some remain small and local, while others blanket the entire globe. Why this happens is still a mystery, one that scientists are eager to solve through long-term observation and climate modeling. The more we learn about Martian dust storms, the more we understand about atmospheric dynamics across the solar system. And comparisons are inevitable. On Earth, sandstorms are shaped by humidity, terrain, and vegetation. On Mars, the lack of moisture allows dust to move freely, turning it into a dominant force in the planet's story. Interestingly, not all dust storms are dangerous to human technology. Sometimes they offer unexpected help. Rovers powered by solar panels accumulate dust over time, decreasing their energy efficiency. But a passing storm can sweep them clean, giving these machines a second life. It's a beautiful reminder of how nature and technology sometimes work together in surprising ways. Understanding Martian meteorology is essential, not only for science, but for survival. As we prepare for future human missions to Mars, forecasting storms will be critical. Astronauts will need to face storms that could disrupt communications, limit visibility, and delay critical operations. Being able to predict these events could make all the difference between success and catastrophe. Martian storms are more than a natural curiosity. They're a mirror, reflecting how fragile and complex planetary systems can be. Each new storm is a lesson, each swirling cloud a chapter in the book of Mars's past. In every grain of dust, there's a story waiting to be uncovered, about formation, erosion, and transformation. At the end of the day, the weather on Mars reminds us that a planet's climate can be as dynamic and unpredictable as life itself. It invites us to reflect on what it means to live in a world that's constantly changing, and how we, too, must adapt. So, the next time you look up at Earth's sky, remember, somewhere out there, on a distant red world, Mars is spinning beneath a dance of dust and wind, a silent spectacle that continues to captivate scientists and dreamers alike.
What if I told you that Mars experiences dust storms so enormous they can swallow the entire planet? Yes, that powerful. These storms can last for weeks, sometimes months, and their intensity rivals the force of a hurricane on Earth.
Imagine a vast red desert stretching to the horizon. Mars's surface is covered in fine dust and sand, swept up by winds reaching speeds of up to 100 kilometers per hour. But what triggers these storms? The answer lies in the planet's peculiar atmosphere and its seasonal rhythms. Like Earth, Mars has seasons, but its storms are far more extreme. During the spring and summer in the southern hemisphere, temperatures rise, causing carbon dioxide at the poles to sublimate, that is, turn directly from ice to gas. This release increases atmospheric pressure, setting off powerful winds that fuel colossal storms. One of the most fascinating aspects of these Martian storms is their ability to evolve. They often begin as small gusts of wind, lifting a few grains of dust. But how do they grow into storms that stretch across thousands of kilometers? The secret is in the layers of Mars's atmosphere and how dust behaves like a snowball rolling down a hill. As more dust is lifted, the storm feeds on itself, growing larger, darker, and more powerful. Now, imagine such a storm wrapping itself around the planet. The sunlight fades, the temperature plummets, visibility drops to zero. It becomes a world of shadows and silence. These storms aren't just dangerous, they challenge every mission sent to explore Mars. Solar power is lost, communication weakens, rovers are left blind. Yet, in some strange way, could these storms also serve a protective role? When the dust settles, it can alter the very surface of the planet, reshaping terrain, burying rocks, and erasing the footprints of past explorers. Studying these processes is vital to understanding Mars's geological history and how it has changed over millions of years. But it also complicates our efforts to analyze past missions and locate important markers. Despite their challenges, Martian dust storms provide a unique opportunity to learn, not just about Mars, but about our own planet too. By observing how these storms form and move, scientists gain insights into atmospheric behavior, patterns that may even help us understand Earth's climate better. Comparing Earth's sandstorms to Mars's dust storms is fascinating. On our planet, sandstorms are dangerous, but often localized and short-lived. On Mars, they are planetary-scale events. The difference lies in the atmosphere. Earth's thick atmosphere, rich in moisture, helps control storms. Mars's dry, thin air allows dust to roam freely, creating a landscape where the wind tells the story. And what if these storms affect more than just the surface? Some scientists wonder whether dust storms might impact the possibility of life on Mars. Could they stir up buried water, reveal ancient layers of the terrain? If life ever existed there, perhaps these storms played a role in its survival or extinction. In the end, Martian dust storms are more than weather events. They are signals from a world in motion, a living canvas painted by wind and time. Next time you think of Mars, imagine a dusty sea swirling across a crimson land, a place where storms move like titans, reshaping the planet with every gust. Exploring them is more than science. It's a journey towards understanding our own place in the universe. Now, what makes Jupiter, our solar system's gas giant, so captivating? Among many wonders, its atmosphere is a masterpiece of storms. At its heart swirls the Great Red Spot, an enormous hurricane so vast it could swallow Earth whole. Can you imagine a storm lasting more than 300 years? That's exactly what happens on Jupiter. Its storms don't just form, they endure. Gazing into the red spot, it's easy to get lost in its rich colors and spirals, but what powers it? Unlike Earth, where solar heat drives most weather systems, Jupiter generates much of its energy from within. The planet's immense gravity compresses its interior, creating heat like a pressure cooker. This internal warmth fuels an atmosphere of churning gases, complex currents, and violent winds. Jupiter's rapid rotation also plays a key role. The entire planet spins on its axis in just about 10 hours. This fast rotation creates powerful jet streams, some reaching speeds of up to 600 kilometers per hour. Winds so strong they could tear through anything in their path. Its atmosphere is made mostly of hydrogen and helium with traces of methane, ammonia, and other gases. These elements combine to form spectacular cloud layers, stripes and swirls that shift and blend in a mesmerizing dance. What would it feel like to stand in a storm on Jupiter? Unimaginable. These aren't isolated tempests. Jupiter's entire atmosphere is alive with rolling cloud belts and constant storms. Some fade quickly, others, like the red spot, defy time. Why do some last for centuries while others vanish in days? That's one of the great mysteries scientists hope to solve. Jupiter's sheer size is part of the answer. With a diameter 11 times greater than Earth's, its atmosphere offers enormous space for storms to evolve, grow, and interact. It's like a vast ocean of wind stretching farther than the eye can see. Studying Jupiter's weather isn't easy. Spacecraft have given us stunning images, but many questions remain. How do these storms begin? What keeps them alive? Each new mission, like NASA's Juno probe, brings us closer to unlocking those answers. And although Jupiter is hostile to human life, some scientists speculate its upper clouds might contain the ingredients for microbial life. Could there be floating organisms in the sky of Jupiter? The idea sounds like science fiction, but if we've learned anything, it's that life is more resilient than we imagined. Maybe not in the same forms we know, but in forms shaped by chemistry, not comfort. Even Jupiter's smaller, lesser-known storms offer clues. Some are just as intense as the Great Red Spot, but haven't gained the same fame. Each is a reminder that in nature, it's not just the giants who matter. Every storm tells a story. The storms of Jupiter are a world unto themselves, complex, beautiful, and vast beyond measure. Studying them not only deepens our knowledge of this distant planet, it sheds light on how storms work here on Earth too. Could there be connections between the storms of Jupiter and our own climate systems? The answer might reshape our understanding of weather and even climate change. Finally, as we reflect on Jupiter's role in the solar system, we must remember, its storms are more than just violent displays. They are a part of a dynamic system shaped by gravity, energy, and motion. Each one is a living testament to the power and mystery of the cosmos. And as our exploration continues, we can only imagine what else this gas giant still has to reveal.
What happens when immense internal pressure combines with the planet's own heat? Jupiter, our solar system's gas giant, has never fully cooled since its formation over 4 billion years ago. Unlike Earth, Jupiter continues to radiate heat from within, generated by gravitational compression and the decay of radioactive elements. This internal heat rises, forming convective currents throughout its atmosphere. Just as heat from a fire makes the air ripple and dance, Jupiter's internal warmth stirs the massive layers of gas, giving birth to storms that seem eternal. The combination of gravity and heat doesn't just spark storms, it sustains them for centuries. On Earth, storms come and go, lasting days or weeks. On Jupiter, some have raged for centuries. Take the Great Red Spot, for example, a titanic hurricane that could engulf Earth entirely. It has been spinning in Jupiter's atmosphere for over 300 years. But how is that even possible? The answer lies in the planet's unique atmospheric dynamics. Jupiter's atmosphere is composed mostly of hydrogen and helium, but it also contains other compounds like ammonia and water vapor. each playing a role in the chemistry and physics of its weather systems. In this gaseous world, wind speeds can exceed 200 kilometers per hour in some regions. As different air currents meet and collide, they generate pressure systems that grow into enormous storms, like ingredients blending into a thick, swirling mixture. Another astonishing feature of Jupiter is how quickly it spins. This massive planet completes a full rotation in less than 10 hours. This rapid rotation creates powerful centrifugal forces, influencing how storms form, how they move, and how they persist. Unlike Earth, where weather systems meander slowly, storms on Jupiter organize into bands, zones of wind moving in alternating directions. These wind bands stretch around the entire planet, creating a striped pattern that is both beautiful and chaotic. Now imagine those bands as conveyor belts of energy, each feeding into the birth and growth of storms. And here's where things become even more intriguing. Despite the extreme conditions of its atmosphere, some scientists believe Jupiter might contain the right ingredients for life, not on its surface, but in the upper layers of its clouds. Could life exist in such a stormy, volatile world? In the upper atmosphere, high above the crushing pressure and intense heat of the lower layers, conditions become more gentle. Temperatures are less severe, and the chemistry becomes fascinating. It is here, in the calm above the chaos, that scientists focus their hopes. The clouds of Jupiter are a swirling mix of hydrogen, helium, ammonia, and water vapor. Each of these compounds is essential to known biological processes. Ammonia, for instance, could serve as a source of energy from microorganisms. If the right chemical conditions exist, what would stop life from forming, even in such an alien place? Even more compelling, recent studies have hinted at the presence of phosphorus and other elements critical to life. But how do we know this isn't just science fiction? Data from past missions has revealed signs of complex chemistry. Some processes observed in Jupiter's atmosphere mirror those we've seen on Earth, in extreme environments where life does survive. On Earth, we find life in the boiling vents of the deep ocean, in acidic lakes, and in frozen deserts. If life can exist there, why not in the clouds of Jupiter? One of the most compelling questions is, how could we detect such life? The answer lies in future missions, probes that may one day fly through Jupiter's clouds, collecting atmospheric samples and analyzing their composition in real time. Picture a tiny spacecraft drifting through those golden clouds, searching for the faintest whispers of biology in the upper atmosphere. What surprises might it reveal? For decades, the search for life beyond Earth has captivated scientists and dreamers alike. The idea that we might not be alone in the universe is both thrilling and humbling. But it's important to remember, discovery doesn't come from hope alone. Science moves step by step. Each piece of evidence is tested, each possibility is examined. It's a slow but exhilarating journey toward truth. And Earth itself reminds us of the possibilities. Life here is astonishingly adaptable. Microbes survive under pressure, in boiling temperatures, in acid, in radiation. Some even thrive in the sky. Could similar organisms be floating above the clouds of Jupiter? Creatures we can't yet imagine. Lightweight, microscopic, sustained by chemicals and warmth rather than soil or sunlight. If life does exist in Jupiter's clouds, the implications would be profound. It would change our understanding of biology, of planetary evolution, of our place in the cosmos. What would it mean for humanity to discover life not just on a neighboring moon or rock, but in the skies of a storm-racked gas giant? These questions go beyond science. They are philosophical, even existential. They touch the very essence of what it means to be alive in a vast and mysterious universe. But this search isn't only about distant worlds. Studying Jupiter teaches us about Earth. By exploring how planetary atmospheres form and evolve,
We also learn how to better care for our own fragile environment. Space exploration and Earth conservation are deeply connected, more than we often realize. In that way, Jupiter becomes more than a planet. It becomes a teacher, a mentor in the art of climate, motion, and cosmic balance. Each storm is a lesson, each data point a key to a deeper truth. The search for life in Jupiter's clouds is just one part of a greater puzzle. Science marches forward, slowly and steadily, and each new discovery opens doors to new questions. What once seemed like fantasy is now within reach. We are entering an age when the possibility of life beyond Earth is no longer speculation, it is a scientific pursuit with real momentum. As we continue this journey, let's remember, each answer brings with it a dozen more mysteries. That's the beauty of exploration. Every storm, every molecule, every whisper of possibility reminds us how little we know and how much more there is to discover. The future of space exploration is full of wonder. Each mission, each study, brings us one step closer to understanding our place in the cosmos. The clouds of Jupiter may hold secrets beyond imagination, and the only way to uncover them is to keep asking questions, to keep seeking, to keep reaching beyond the sky.
Have you ever wondered how storms form on distant alien planets? In the depths of our solar system, Saturn reveals one of the most electrifying phenomena ever recorded. Massive thunderstorms, so large they could cover the entire surface area of Earth. But what makes these storms so powerful? Why do they behave so differently from anything we've seen on our own planet? Saturn's atmosphere is a swirling ocean of gases, mainly hydrogen and helium, where the stage is perfectly set for enormous electrical storms. Imagine a world where winds rush with astonishing speed, and energy builds in thick clouds until it explodes in dazzling bolts of lightning, more powerful than any lightning ever seen on Earth. If you could witness a lightning strike on Saturn, it would be breathtaking. A silent, brilliant flash slicing through golden clouds, followed by a reminder of nature's raw and boundless force. These are not isolated events. Saturn's thunderstorms are deeply tied to the chemistry of its atmosphere. When clouds rise, they carry droplets of water and ammonia, creating a volatile blend capable of unleashing titanic electric discharges. Scientists believe that a single lightning bolt on Saturn may release enough energy to power thousands of light bulbs simultaneously. And while storms on Earth typically last for hours or at most days, on Saturn they can persist for months, even years. What keeps them going? The answer lies in the complex atmospheric dynamics of Saturn itself. The interactions between wind patterns and temperature gradients don't just cause storms, they sustain them. With every major storm, Saturn reveals clues, changes in atmospheric color, density, and motion that help scientists decode the mysterious mechanics of its climate. Think of scientists as cosmic detectives, analyzing each lightning flash and pressure shift to uncover the truth behind one of the solar system's most unpredictable environments. But beyond the drama, Saturn's storms are more than a spectacle. They offer a glimpse into planetary processes that could exist elsewhere, even on exoplanets orbiting distant stars. Each storm is a natural laboratory, an open book filled with lessons about climate formation and atmospheric evolution. And the visuals are nothing short of extraordinary. Images from space missions and telescopes have shown bands of swirling clouds painted in surreal shades, burnt yellows, deep golds, even pale blues. Some clouds cast shadows on layers below, creating a three-dimensional scene that resembles a dreamscape more than a real place. Compared to Earth's gentle sunsets, the skies of Saturn feel almost mythological in scale. But Saturn is not alone in its mysteries. Just beyond its rings lies Titan, the planet's largest moon, and a world so unusual it defies expectations. Titan is the only moon in the solar system with a thick, dense atmosphere. In fact, besides Earth, it's the only known place where liquids flow on the surface. But instead of water, Titan's rivers and lakes are made of liquid methane. Let that sink in. A world where methane rains fall from the sky, carving valleys, filling lakes, and shaping a landscape that feels hauntingly familiar and yet completely alien. Titan's atmosphere is mostly nitrogen, laced with methane, and behaves in surprising ways. As the sun sets, temperatures plummet. Thick methane clouds begin to form, wrapping the surface in a cold, swirling fog. It's eerily similar to how storms behave on Earth, except here, the rain isn't water, it's methane. And just like Earth's water cycle, Titan has a methane cycle: evaporation, condensation, and rainfall. Methane, a powerful greenhouse gas, plays a vital role in Titan's climate, helping to regulate its temperature. Could such a world host life? There is no evidence yet, but scientists are deeply intrigued by the possibility. High in Titan's atmosphere, conditions might be gentle enough for life to exist, perhaps not as we know it, but in a form adapted to survive without oxygen. Titan's methane lakes and rivers act as a natural laboratory for studying organic chemistry. They might resemble Earth's early days when life was just beginning to stir in ancient oceans. The absence of oxygen poses a fascinating challenge. But what if life on Titan evolved to use methane as an energy source? Some researchers speculate that microbes could exist beneath the surface, feeding on hydrocarbons in the dark, frigid depths. Imagine an organism that doesn't need oxygen to survive. Such life would reshape our entire understanding of biology. Titan's icy mountains, liquid lakes, and alien weather patterns make it a high-priority target for future space missions. Each probe that approaches Titan's surface brings us closer to answering some of the most profound questions in science. Thanks to missions like Cassini, we've seen breathtaking images of its landscape, geological formations that whisper tales of a world both ancient and dynamic. But even Titan has its share of violence. Methane storms, though less frequent than those on Saturn or Jupiter, can be powerful enough to reshape the moon's surface. And the atmospheric interactions between nitrogen and methane can produce weather events no less spectacular than those of Earth. Imagine a methane storm darkening the skies for days, sweeping across an alien terrain. It's a vision that blurs the line between imagination and reality. Titan even raises the possibility of future human exploration. Could we one day live on this strange moon? The average temperature hovers around -180 degrees Celsius, and the rain would not be welcome. Yet, with protective habitats and advanced technology, Titan could become a stepping stone for humanity's future in deep space. As we continue to explore, Titan serves as both a memory of Earth's past and a vision of what other habitable worlds might look like. But the journey doesn't end there. Venture further into the solar system, and you'll find Neptune, a planet of deep azure blue, mysterious, frigid, and impossibly distant. Yet, despite its remoteness, Neptune boasts some of the most violent weather in the solar system. Its winds are the fastest ever recorded, reaching up to 1,600 kilometers per hour, faster than a commercial jet and stronger than any hurricane Earth has ever seen. How can a planet so far from the sun be so turbulent? Surprisingly, Neptune's weather isn't driven by solar heat. Instead, the planet generates its own internal warmth, possibly from gravitational contraction and the decay of radioactive elements. This heat fuels massive convection currents in its thick, icy atmosphere, an engine that drives storms across the planet with terrifying speed.
Neptune's atmosphere is mostly hydrogen, helium, and a trace of methane. This methane is what gives the planet its signature blue color. By absorbing red light and reflecting blue, Neptune presents a visual unlike anything else in the solar system. And its storms are nothing short of majestic. Dark spots, akin to Jupiter's Great Red Spot, have been observed forming and vanishing within months. Some of these storms have grown larger than Earth, only to disappear as mysteriously as they appeared. These fleeting tempests are part of a complex system where wind, temperature, and pressure interact in ways we still don't understand fully. They create cloud patterns that resemble waves on a restless ocean. They hint at secrets hidden beneath the surface, secrets we've only begun to uncover. From the violent storms of Saturn to the methane rains of Titan to the supersonic winds of Neptune, each planet and moon tells a story. A story not just of gas and gravity, but of possibility. And perhaps somewhere within those clouds or beneath those icy surfaces, the answer to one of humanity's oldest questions lies waiting to be discovered.
Is there more than methane shaping Neptune's strange and stormy atmosphere? The answer, as with so many cosmic mysteries, is there is still so much to discover. One of the most fascinating aspects of Neptune is its seasonal cycle. Even though this distant ice giant is nearly 30 times farther from the Sun than Earth, it still experiences seasons, but not like the ones we know. Neptune's seasons last around 40 years each. Imagine a winter that spans 4 decades. What does that mean for the planet's weather? Scientists are beginning to understand how these long, drawn-out seasons can lead to drastic changes in atmospheric pressure and temperature, changes that might fuel or weaken storms over time. Another strange detail is how Neptune's clouds behave. Unlike Jupiter, where clouds shift constantly and violently, Neptune's seem more stationary, as if held in a kind of delicate balance. Could this be caused by the planet's unique blend of internal heat and solar distance? Neptune's storms are often compared to those of Jupiter, but there are key differences. While Jupiter's Great Red Spot has lasted for centuries, Neptune's storms tend to be short-lived and more intense, flickering in and out of existence like ghostly tempests. This raises important questions about how storms behave under different planetary conditions and how environment shapes both their intensity and duration. In this grand choreography of winds, pressure, and invisible forces, Neptune teaches us that even in the farthest reaches of the solar system, the weather can still surprise us. The more we learn about Neptune's dynamic atmosphere, the more we realize this isn't just a frozen blue dot, it's a world of roaring energy. Each new observation offers clues that help us understand not only this planet, but the very nature of planetary weather, including our own. And just when you think you've grasped the beauty of Neptune, the story expands beyond our solar system, far beyond. What if I told you there are worlds out there, exoplanets, that may experience storms on a scale we can barely imagine? These are planets orbiting stars other than our Sun. Some are gas giants, others are rocky. Some are scorched by heat, others frozen in eternal night. But many of them might have atmospheres, just like Earth, or like Neptune. And some may host extreme weather unlike anything we've ever seen. Imagine a desert planet where sandstorms rage for weeks, covering entire hemispheres. Or a world so hot that hurricanes of fire rip through its atmosphere, blasting molten winds across an alien landscape. The question is, how do we know? Astronomers have developed ways to study these distant worlds using powerful telescopes and advanced techniques. One of the most remarkable methods involves analyzing starlight as it passes through an exoplanet's atmosphere. From the tiniest changes in the light spectrum, scientists can detect gases, clouds, and even hints of storms. Thousands of light years away, we are reading the weather of another world. Some exoplanets are so massive that their gravity traps huge amounts of gas, creating atmospheres thicker than anything we know. In such dense conditions, clouds form like floating oceans, and storms erupt with unimaginable energy. What would it feel like to stand beneath those skies? Would the pressure crush you? Would lightning illuminate the sky in ways our eyes could not even process? And what if, within that chaos, life had found a way to adapt? On Earth, life flourishes in extreme environments, at the bottom of oceans, inside volcanoes, frozen in polar ice. Could there be organisms thriving inside alien storms? Maybe not life as we know it, but something new, something made for those conditions. Even just comparing the weather of exoplanets to what we see in our own system can be deeply revealing. Mars, for example, experiences massive dust storms that blanket the planet. But what if a storm could reshape an entire planet's surface? That's the scale we're talking about on some of these distant worlds. And beyond their immediate beauty or danger, storms might actually shape the birth of a planet. They affect how atmospheres form and evolve, possibly even determining whether a planet can support life. Some exoplanets are located in the so-called habitable zone, not too hot, not too cold, where liquid water could exist. But what if those planets are wrapped in eternal hurricanes? Would life still be possible there? Maybe, but it wouldn't be life like ours. Understanding the extreme weather of other planets helps us understand Earth better too. As we study how atmospheres function under different conditions, we learn more about our own climate and how it's changing. Could the storms of distant planets help us protect our own? It's a question that blends curiosity with responsibility. And yet, our journey doesn't end with storms. There's another class of traveler in the solar system, one that's been visiting us for billions of years: comets. These icy wanderers are among the oldest, most enigmatic objects in space. But what are they exactly? Comets are composed of ice, dust, and rock, frozen relics from the solar system's earliest days. When they approach the sun, the heat causes the ice to sublimate, transforming directly into gas and creating those glowing tails that stretch across the night sky. For ancient civilizations, comets were harbingers of change. Today, we know they are messengers of the past. Some scientists believe that comets may have delivered the very building blocks of life to Earth: water and organic compounds. Imagine every passing comet as a cosmic delivery, a frozen package carrying essential ingredients to a young, barren planet. But comets are not always gentle. They've also been responsible for cataclysmic impacts, including the one that may have wiped out the dinosaurs. They are both creators and destroyers, symbols of the universe's dual nature, chaotic and beautiful. One of the most famous of these is Halley's Comet, which appears every 76 years. Each time it returns, it offers a chance to see a piece of ancient history fly by. But what if the next comet isn't Halley's? What if it's something unexpected, on a collision course? The fear is real, but so is the science. Today, astronomers monitor comets closely, calculating their paths with precision and preparing for the day when we may need to defend our planet. And maybe, in studying them, we'll find not just threats, but also answers. Answers about where we came from and what else might be waiting for us out there.
Are there real plans to deflect a comet if one were ever headed our way? Surprisingly, yes. Scientists around the world are developing ways to not only study, but, if necessary, redirect the path of a potentially dangerous comet. It might sound like science fiction, but the work is real, and it's urgent. In many ways, astronomers are like archaeologists of the cosmos, piecing together the history of our solar system through every fragment of ice, dust, and rock that floats through space. Each mission,
Each telescope observation adds another puzzle piece. Yet the fascination with comets stretches far beyond science. Across centuries and civilizations, comets have been symbols, omens in the sky. To ancient cultures, they were signs of change, carrying with them both hope and dread. Even today, comets still capture our imagination. From movies to myths, they've become icons of cosmic drama, harbingers of fate. But in the scientific world, comets have taken on an even more profound role. They may hold the key to life itself. Imagine for a moment, a frozen traveler from the edge of the solar system crashes into a young Earth. Inside it, not just water, but organic molecules, the building blocks of life. Could it be that these icy bodies were cosmic architects, sowing the seeds of life? That idea is not just poetic, it's increasingly backed by data. As we explore deeper into space, comets are proving to be time capsules, preserving material from the birth of the solar system. Take, for example, the Rosetta mission, which landed on Comet 67P. That moment was more than just an engineering triumph. It was a window into 4 billion years of history. By studying how comets formed, what they're made of, and how they behave, we learn about our own origins. Some scientists believe that much of Earth's water may have arrived on comets. And if that's true, then comets didn't just bring ingredients for life, they brought life's foundation. Now, imagine how many other worlds might have received similar gifts. Moons like Europa and Enceladus, icy and distant, may have hidden oceans beneath their frozen shells. Could comets have helped deliver water there too? We're only beginning to ask these questions. At the same time, comets remind us of something more sobering. They can destroy as well as create. Behind their glowing beauty lies immense potential energy. One impact, one miscalculation, and the results could be catastrophic. One of the most famous examples? The extinction of the dinosaurs, an event believed to have been triggered by a comet or asteroid slamming into what is now the Yucatan Peninsula in Mexico. The collision reshaped Earth's climate, caused mass extinctions, and reset the evolutionary clock. Comets are messengers, yes, but sometimes they bring destruction. That's why scientists track them with such precision. Using telescopes and orbit models, astronomers can now predict the paths of many near-Earth objects. And they're preparing. Plans have been proposed to nudge or even break apart incoming comets using spacecraft or controlled detonations. It might sound like the plot of a movie, but the research is very real and potentially life-saving. In this sense, comets teach us not only about space, but about our own vulnerability. They remind us how fragile Earth is and how deeply interconnected we are with events far beyond our atmosphere. But the story of comets isn't just tied to Earth. These cosmic nomads have likely played roles in shaping other worlds too. They may have contributed to the formation of atmospheres on other planets, or delivered essential elements to moons we've barely begun to explore. And now, as we peer into distant star systems, we're finding something incredible. Exocomets, comets orbiting other stars. This discovery suggests that the drama of comets is not unique to our solar system. It's part of a universal story. Perhaps these distant travelers are carrying water, organic molecules, and ancient secrets to other planets just like ours. Could they also spark life elsewhere? The mystery deepens. From a cultural perspective, comets have always left their mark. In ancient texts, they were seen as divine messengers, sometimes foretelling disaster, other times bringing transformation. They were feared, worshipped, and revered.
Even now, when a bright comet streaks across the night sky, it awakens something primal in us, a feeling of awe, of connection, of humility. In the age of space telescopes and deep space missions, comets continue to be symbols of the unknown. Each time one visits our sky, it brings new chances to learn, not just about the solar system, but about ourselves. Comets teach us that the cosmos is full of paradox, creation and destruction, beauty and terror, light and shadow. They are icy time machines forged in the cradle of the universe, and every one of them carries the potential to change history. So the next time you see one, remember, it's not just a trail of light in the dark. It's a message from the past, for the future, and maybe for you.
What lessons can we learn from comets? History warns us of the dangers these celestial travelers can bring, but it also invites us to reflect on the fragile nature of life on our planet. Comets, beyond being agents of destruction, have captivated humanity's imagination for centuries. They have been seen as omens, bearers of divine messages. But what do comets really represent? They are reminders of the vastness of the universe and of our fleeting existence within it. Every time a comet approaches Earth, it offers a chance to pause and reflect on our place in the cosmos. Science has made great strides in understanding comets and their paths. Astronomers have developed methods to track these objects and predict their movements. Yet despite all our advances, much remains unknown. How can we be certain that no comet will ever head directly toward us in the future? Constant vigilance of the skies has become essential. The scientific community works tirelessly to identify potential threats and to devise ways to divert them. Space missions have been fundamental in studying comets. Probes have traveled billions of kilometers to approach these frozen bodies and collect precious data. The Rosetta mission, for example, made history by landing on Comet 67P in 2014, providing invaluable insight into its composition. These explorations not only deepen our knowledge of comets, but also help us understand the origin of the solar system, and potentially of life itself. The question of how to defend ourselves from comets remains one of science's greatest challenges. Some scientists propose using spacecraft to gently nudge a comet off course. Others suggest the use of nuclear explosives to break it apart. However, these strategies are still theoretical and require extensive research and development. One of the most fascinating things about comets is that although they can be destructive, they also offer opportunities to learn. Every time a comet passes near Earth, it reminds us how little we truly know about our cosmic environment, and it urges us to seek answers. Human curiosity and the drive to explore are powerful forces that have led us to discover wonders across the universe. Ultimately, the story of comets is a reflection of our own. By understanding their impact on Earth, we not only learn about the past, but also prepare for the future. Space exploration and monitoring of these celestial bodies are essential to our survival. Comets, in their dual role as creators and destroyers, teach us that the universe is full of mysteries and opportunities. So next time you look up and see a shooting star, remember, it might be a comet, a traveler from the depths of space that has journeyed a long way. In some way, it is tied to the story of life on Earth. Comets are not just icy bodies drifting in the void. They are pieces of a cosmic puzzle that help us understand our past
and prepare us for what to come. Earth is a beautiful blue planet sailing through the vast cosmos. But like any good hero story, it has villains. One of the most formidable are comets. These icy travelers have crossed our cosmic neighborhood for millions of years, and their story is full of surprises. But how do we defend ourselves from these dangerous visitors? To understand Earth's defense, it's key to know that comets are like dirty snowballs orbiting the sun. They're made of ice, dust, and rocks, and when they get close to the sun, their ice turns into gas, creating a bright atmosphere visible from Earth. Imagine if one day, one decides to head straight toward us. It might sound like a sci-fi plot, but it's a real possibility. For centuries, scientists have watched the skies, tracking these comets with advanced telescopes. They've developed ways to trace their paths, like detectives following clues to solve a mystery. But what if we discover a comet on a collision course with our home? What can we do to protect ourselves? One of the most intriguing strategies involves spacecraft. Imagine a comet months away from Earth. Scientists could send a probe to study it, and if needed, deflect it. How would that work? One idea is to strike the comet with a small explosive device, a gentle push to alter its trajectory. Though it sounds simple, it's an incredibly complex calculation, like trying to nudge a giant rolling boulder down a hill. Others propose harnessing the sun's power. If a comet has an icy core, we might heat its surface with powerful lasers or giant mirrors. By evaporating the ice, pressure would build and push the comet in a new direction. It's cosmic billiards, but all this requires technology still in development. Prevention also plays a vital role. Education and preparation are key. If a comet threatened Earth, emergency plans would be crucial, ranging from public alerts to safe shelters. Much like a tropical storm, where preparation and information save lives. What about simulations? Scientists create computer models to better understand comet behavior and the likelihood of a collision. These simulations are like video games, except instead of saving a princess, they're saving humanity. But it's not all worry and caution. The history of comets is filled with thrilling moments. Ancient cultures saw them as signs of momentous events, from wars to great discoveries. Today, we know comets are not only threats, but also carriers of secrets. Did you know that comets might have brought water and organic compounds to Earth, essential ingredients for life? By studying comets, we not only seek protection, but also strive to understand our origins. What can these travelers tell us about the birth of the solar system? Every comet passing near us could be a time capsule, a reminder of how our home formed in the vast universe. The pursuit of comets is not just about defense. It's a window into our planet's history and life itself. By learning about them, we learn about ourselves. In this way, science and space exploration become our greatest allies. Every mission launched, every telescope pointed skyward, brings us closer to understanding our place in the cosmos. Defending Earth isn't just about technology. It's about knowledge and curiosity. So next time you see a shooting star in the night sky, remember, it could be a comet, a traveler on a long journey. And while we watch in wonder, it's comforting to know humanity is working every day to protect our planet and to better understand the mysteries of the cosmos. The story of comets is above all a story of hope and discovery, where human curiosity shines brighter than any star in the night sky.
What secrets will the future reveal to us? The answer lies in the hands of scientists, engineers, and dreamers who never cease in their quest to discover. When we look beyond our home, we find not only planets and moons, but also the possibility of new worlds.
There are thousands of exoplanets orbiting distant stars, and some of them might have conditions similar to Earth. Could it be that out there, other beings, other civilizations are looking up at their skies with the same curiosity we have? The search for life on these distant worlds is one of modern science's most intriguing questions. Each discovery brings us a little closer to the answer. Exploring other planets is not only an act of scientific curiosity, it is also a matter of survival. As we face challenges here on Earth like climate change and overpopulation, the idea of colonizing new worlds grows ever more compelling. What if we find a habitable planet? It would be a new opportunity, a fresh start for humanity. Yet, this vision comes with many ethical and technical challenges that we must carefully consider. Space exploration also teaches us about the fragility of our own planet. By observing the climates of other worlds, we better understand Earth's dynamics. Storms, winds, and atmospheres on those planets offer lessons on how to care for our home. They remind us that we are part of a much larger system and that our actions have consequences beyond what we see. The science behind space exploration advances by leaps and bounds. Our progress depends less on luck and more on technology and accumulated knowledge. With each mission, techniques improve, and new tools allow us to see farther and clearer. What surprises will the coming decades bring? The excitement within the scientific community and space enthusiasts is palpable. However, the path is not easy. Space exploration requires significant investment and a long-term commitment. Is it really worth it? The answer is yes. Every time we look up and discover something new, we push the boundaries of our knowledge. We create opportunities for future generations of scientists and explorers. The legacy of exploration is not measured only in discoveries, but in the inspiration it sparks in young minds, those who may one day become astronauts, engineers, or scientists. International collaboration plays a crucial role in space exploration. Isn't it fascinating that nations from around the world can unite in the pursuit of knowledge? Projects like the International Space Station show how working together can take us farther than we could ever go alone. Space exploration is a collective endeavor that demonstrates humanity's ability to come together for a common goal. As we continue to explore, we must also remember the responsibility we hold toward the universe. The search for life on other planets and the colonization of new worlds must be conducted ethically and sustainably. What does this mean for us? It means we must be careful and respectful of the places we visit, just as we are with our own planet. Exploration should not become a new form of colonization, but rather an effort to understand and coexist. Science and exploration are not just for scientists, they are for everyone. Each discovery has the power to change how we see the world and our place within it. Curiosity is a spark that can ignite a passion for science in anyone. So why not let that spark become a blazing fire? Space exploration is a journey we can all share, a path filled with wonders and lessons. Ultimately, space exploration is more than just science. It reflects what it means to be human, the desire to go beyond, to understand the unknown, and to dream of what might be. Looking toward the future, let us always remember that every mission, every discovery, and every question we ask is part of a shared journey that transcends borders and time. Space exploration calls us all to be part of this adventure, to keep dreaming and keep exploring.
The search for life in other solar systems takes us into a vast universe full of mysteries and possibilities. What if worlds similar to Earth exist, places where life could flourish just as it does here? The idea that we might not be alone in the cosmos has fascinated scientists and dreamers alike. Every new discovery of exoplanets, those worlds orbiting distant stars, strengthens the belief that life might exist in forms we have yet to understand. Consider for a moment the incredible diversity of environments on our own planet. From the frozen tundras of the Arctic to the hot tropical jungles, life has adapted to extreme conditions. Doesn't it seem reasonable that life could also find a way in other corners of the universe? Scientists have identified thousands of exoplanets, some located in the so-called habitable zone, the region around a star where conditions might allow liquid water to exist. Water, the elixir of life, appears to be an essential ingredient. However, finding water alone is not enough. Atmospheric conditions, temperature, and the planet's chemistry are fundamental in determining if a world can support life. How do we seek answers to these questions in such an immense space? Space missions are key. Using advanced telescopes and probes, scientists analyze starlight passing through exoplanet atmospheres. This process, called spectroscopy, reveals their composition, searching for signs of oxygen, methane, and other compounds that could indicate biological activity. Imagine a star's light telling scientists the story of a distant planet, unveiling clues about its habitability. Yet, the search for life is not limited to Earth's neighborhood. Sometimes scientists look in unexpected places within our own solar system. Moons like Europa, one of Jupiter's moons, and Enceladus, a moon of Saturn, hide oceans beneath their icy surfaces. These conditions might be ideal for microbial life. What secrets could be hidden beneath that ice? Life might not always mean complex beings like us. It could be simple and microscopic, similar to the first organisms that inhabited Earth. But what if we one day find a clear signal of intelligence from another world? The search for radio signals, like those advanced civilizations might send, is a fascinating field. Projects like SETI, the search for extraterrestrial intelligence, are always on the lookout for anomalies that could indicate other civilizations. Recent discoveries have challenged our assumptions about where and how life might exist. Until recently, it was thought that life could only thrive in Earth-like conditions, but we found extremophiles, organisms living in extreme environments here on Earth, suggesting that life might be far more versatile than we imagined. This opens the door to life adapting to environments we once considered inhospitable. As we explore more and more exoplanets, we must also consider the diversity of star systems. Some planets orbit red dwarf stars, which are cooler and less bright than our sun. Could these worlds host life despite their different environments? The answer is uncertain, but every new discovery brings us closer to solving this mystery. The concept of life itself might be broader than we think. What if life on other worlds manifests in ways we've never seen? Perhaps silicon-based organisms instead of carbon-based ones, or life forms that don't depend on water as we know it. These ideas might sound like science fiction, but they challenge us to expand our minds and consider the incredible variety of what might exist. The search for life beyond our solar system is not just academic. It holds profound implications for humanity. If we find life, especially intelligent life, we face philosophical and ethical questions that could change how we see our place in the universe. How would we interact with other forms of life? What responsibilities would we have towards them if we find them? Space exploration is an adventure that will surely take us to unimaginable places.
As we advance in our search, it is vital to remember that every discovery brings us closer not only to understanding the cosmos, but also to understanding ourselves. In the end, the search for life in other solar systems is not only about finding habitable worlds, it is about reflecting on the nature of life itself and our role in this vast universe. Every star in the sky could be home to a world waiting to be discovered. Human curiosity drives us to keep searching, keep questioning, and never stop dreaming.
Who knows what discoveries the future holds? The answer might be just around the corner, in a corner of the universe we have yet to explore. In this quest, every step we take is a step toward knowledge, wonder, and hope. The future of humanity in space is a topic that inspires both curiosity and optimism. Perhaps, in the not-so-distant future, we will live and thrive on other planets. The idea of colonizing distant worlds has evolved from science fiction dream to a real possibility, with new strides being made every day. Since the dawn of space exploration, we have felt a deep need to venture beyond our home. But what awaits us on these new worlds? Colonizing other planets raises many intriguing questions. For example, how could we survive in a harsh environment like Mars, where temperatures can be extreme and the air is unbreathable? The answer lies in innovation and technology. Imagine cities built under protective domes where people can live and work in a controlled environment. With the right technology, we could grow food in greenhouses and generate oxygen from local resources. The idea of turning Mars into a second home doesn't seem so far-fetched, does it? However, colonization is not just about survival, it is about adaptation. How could humans adjust to living on a planet that is not Earth? The key might be human ingenuity, from spacesuits that regulate temperature and pressure to self-sustaining habitats. Technology offers endless possibilities. Imagine living where the sky has a different color and the nights are filled with stars you've never seen before. The adventure of living on another planet is unparalleled. When thinking about the future in space, sustainability is crucial. We don't just want to survive, we want to thrive. Interplanetary travel is not limited to the first colonizers. What about future generations? How can we ensure our impact on new worlds is positive? The answer lies in education and responsibility. If we start thinking of space as an extension of our home, we could develop a culture that values protecting these ecosystems just as we do on Earth. Space exploration also presents an ethical dilemma. Is it right to colonize other planets? Should we interfere with ecosystems that might exist there? Reflecting on these questions is essential as we move toward colonization. Perhaps, instead of conquerors, we should see ourselves as caretakers of the cosmos. This shift in perspective could be fundamental for a harmonious future in space. As we enter the 21st century, international cooperation becomes essential. Could countries unite to form an interplanetary community? History teaches us that collaboration leads to great achievements. The International Space Station stands as proof of what can be accomplished when nations work together. Imagine a future where geographical borders no longer matter in space. It's a dream that could become reality. Traveling to other planets might also deeply impact our understanding of the universe. How will living in a different environment transform us? Adapting to new worlds might answer questions we haven't asked yet. We could discover new forms of life, or even clues about our own origin. Every step we take in space exploration could unveil profound mysteries. The search for new horizons is not limited to Mars or the Moon. What if one day we venture toward exoplanets? With advances in telescope technology, we can now detect planets around other stars. Some are in the habitable zone, where liquid water might exist. The possibility of finding an Earth-like planet is fascinating. One day, we might travel there and establish a new civilization.
Developing space transportation technology is another key factor. How will we travel between planets? Spaceships need to be fast and efficient. Concepts like nuclear jet propulsion or solar sails are on the table. Imagine traveling between planets in days instead of years. Speed and efficiency will be crucial to making colonization a reality. Space is not just a place to live, it is a vast laboratory. Here, we can study phenomena impossible to observe on Earth. Microgravity allows us to investigate how materials and organisms behave in different conditions. The lessons learned in space could revolutionize medicine, engineering, and biology. Space exploration is not only about survival, it's about learning and growing as a species. While dreaming of a future in space, we must not forget the importance of our home, Earth. Living on other planets might teach us to care better for our own world. The need to preserve the environment has never been more urgent. Space exploration could offer new perspectives to help us tackle the problems we face here. The future of humanity in space is not just about survival, it is a chance to redefine who we are. Looking up at the cosmos, we have the opportunity to create a society that values diversity, cooperation, and respect for all forms of life. Ultimately, colonizing other planets could be a continuation of our story, a story still waiting to be written. Space exploration is a journey into the unknown. Each step brings us closer not only to new worlds, but also to a deeper understanding of ourselves. Human curiosity, that spark that drives us to explore, will keep guiding us toward new frontiers. Who knows what discoveries await us in the vast universe? One thing is certain, the journey has only just begun. The study of weather phenomena in our solar system gives us a window into the universe's mysteries. What do storms on other planets teach us about Earth, and ultimately, about ourselves? Every corner of the cosmos holds surprises that challenge our understanding and awaken our curiosity. Weather phenomena are not just about rain or wind. In space, they can be extreme and fascinating. Dust storms on Mars, for example, can cover the entire planet. On Jupiter, the Great Red Spot has raged for centuries. These events are not only impressive in scale, but also teach us about atmospheric dynamics. What similarities and differences do we find with our own climate? Earth's history is marked by diverse and changing weather. From devastating storms to prolonged droughts, each event has left its mark on life's evolution. But what if we could apply what we learn from other planets to our own existence? Could understanding hurricanes on Venus or storms on Saturn help us better predict our climate and prepare for natural disasters? The answer is a resounding yes. The science of meteorology is not limited to one planet. It is an interconnected field spanning the entire solar system. When thinking about life, it's exciting to consider that maybe we're not alone in the cosmos. The search for life in Venus's clouds or methane rains on Titan reminds us that habitability may be much broader than we imagined. What conditions are necessary for life to thrive? Maybe it's not just water and temperature, but a combination of factors manifesting in unexpected ways on other worlds. Space exploration offers us more than data. It gives us a new perspective on our place in the universe. Each mission to another planet is a step toward understanding how we function here on Earth. By studying climates of other worlds, we learn more about Earth's history and how it has changed over millions of years. What lessons can we take from those extreme climates to face climate change challenges in our own atmosphere? Looking to the future, colonizing other planets seems less like science fiction and more like a real possibility. But are we truly ready to live on a planet with massive electrical storms like Saturn's or under the crushing pressure of Venus? Exploration not only helps us find new homes, it teaches us about life's resilience and adaptability. Every discovery in space reminds us that the universe is vast and full of surprises. It invites us to question what we believe is possible. We might find life in places we never imagined. The search for Earth-like exoplanets is just the beginning of an adventure that could change our understanding of life itself. The connection between meteorology and life is profound. Storms on other planets are not just natural events, they are reminders of how fragile and resilient life is. Every drop of rain, every gust of wind carries the history of a planet. How has climate influenced the evolution of species on our world? And how will it shape future generations that might live on other worlds? As we reflect on our exploration of the cosmos, it's crucial to remember the importance of science and knowledge. Every time we look up at the sky, we connect to something much greater. Isn't it fascinating to think that the same principles governing storms on Jupiter also apply to storms here on Earth? That connection unites us in our quest for answers. Finally, space exploration is a shared journey. It's not just for astronauts and scientists. We are all part of this quest to understand our place in the universe. Human curiosity is a powerful force that pushes us to look beyond the known. And as we keep exploring, we discover that every planet, every moon, every atmospheric phenomena has something to teach us. Human history is intertwined with the cosmos. In every storm, in every gust of wind, we find not only a reflection of our world, but also an echo of our dreams and aspirations. What future awaits us in this vast expanse of stars and planets? The answer lies in our exploration, our curiosity, and our ability to learn and adapt.